Hello and welcome everyone to the Varsity Tutors StarCourse series, where I think by now we're all very familiar with the term artificial intelligence. But if we were asked some follow-up questions on it, we'd all have to admit we're not entirely sure what artificial intelligence is or does or how we should feel about it. And so today we're going to dive in deep to learn about artificial intelligence with some of the world's best real intelligence. That's right. We've got Samaira Mehta here. She's the founder of Coder Minds, Coder Bunnies, and Yes, 1 Billion Kids Can Code. And she's here to tell us all about what AI is, how it works, what you can do to be involved, and how you and your generation can use it to change the world. So artificial intelligence really only works with at least a little bit of human intelligence powering it, and that's what we're going to ask you to do today. So before we get started, I want to make sure you know your jobs. One, to the right of the screen, you see a chat panel and a polling area. We want you to use that often. Samira's going to ask you some questions to find out what you know and think about artificial intelligence throughout the class, and we're going to harness that to really let our AI work here. So make sure you're answering her questions there. And if you have any questions whatsoever through today's class, drop those in the chat. And in the last 10 minutes, I'm going to take your questions, interview Samaira, and we're going to get as many answers as possible for you using real human intelligence there toward the end of the class. Now, one other thing, we're going to talk a lot about image recognition and using images with AI. And so we want to make sure you get a chance to get some amazing images to remember your experience hereby. So have a camera nearby. In about a half an hour, we're going to give everyone an opportunity to lean into the screen, take a selfie with Samaira to commemorate your experience here. And if you post it to Instagram, which I do hear is back up and online after a weird day today, and tag Varsity Tutors and Coder Bunnies, you'll be entered to win a copy of Coder Minds, the AI board game that Samaira created, and a spot in a Varsity Tutors after school club this year. So with all that said, it's time to turn it over to our real human intelligence to tell us about artificial intelligence. Your teacher for today, Samaira Mehta.
Hello, everybody. Thank you so much. And thank you so much for having me. I'm so excited to be talking with you all about the wonderful world of artificial intelligence. So if we can pull up our visual real quick, I can take you guys through what we're going to be doing and exploring in today's class. So first, we want to talk a little bit about what artificial intelligence really truly is. I'm sure, as Brian mentioned, lots of you guys have heard the term artificial intelligence, but today we're going to dive deep into what it really is, and then how does it really work? So that's our section 1 and section 2. And finally, we're going to be talking about how artificial intelligence can positively change the world. By the end of today's class, you'll have a very nice and very comprehensive understanding of what AI is and how we're going to use it to change the world for the better. All right, so I want to hear a little bit from you guys, right? Who here feels confident that they know what artificial intelligence is? Go ahead and type it in the chat. I'm excited to read some of your responses. Just type yes or no, or maybe what you feel like artificial intelligence is. All right, we're already getting some amazing answers. A lot of you guys do not feel confident that you know what artificial intelligence is. Some of you do feel confident, but hopefully by the end of today's class, we're going to change that. And we're going to make you very confident and make sure that you know what artificial intelligence is. All right, so I want to just, talk sort of loosely, quickly, first just explaining AI and machine learning. All right, so essentially, we give computers a lot of information. That is the core and the base of AI. We train a computer with lots and lots of different information. Specifically today, we're going to be talking about the images that we train a computer with. So we essentially start out by giving computer tons of examples of a certain image, and then we tell them what they're seeing. So for example, if we're talking about cars, right, and let's say we're talking about a Tesla specifically, we can show and give the computer many images of a Tesla car, and then tell the computer specifically that, hey, this car that you're seeing right now, that is a Tesla. And that is the basis of artificial intelligence, the training. So at its core, artificial intelligence is training a computer with a bunch of images or whatever information that is. So you start out by giving the computer lots of data. Then you tell the computer what this data is. So in the example I was just talking about, we give the computer tons of images of cars and we tell the computer, hey, all these images that you're seeing right now, those are cars, more specifically a Tesla car. And so what the computer does is it learns the patterns and specific features and the relationships that make up one certain image. But we use computers because computers can understand and learn these patterns much faster than we humans ever could. And that is what makes artificial intelligence so powerful. It can think way faster than humans can. So let's start over, all right? We start by giving the computer lots of images and lots of training data of what a, let's say, car, or specifically a Tesla car is. The computer learns the patterns that makes up that one image. And finally, after it learns the patterns, when we give a computer a completely different image of a car, that is still a Tesla, and we know that it's a Tesla, but we give it to the computer, that it will also recognize it as that same Tesla car, because from step 2, it understood all the patterns that make up an image. And at its core, that is what the image recognition part of artificial intelligence is. 3 simple steps: training, then the computer understanding the patterns and the features that make up the image, and finally, the computer making new decisions and better predictions on new images. So let's say I have a new image of a car, and I don't know whether this car is a Tesla or a Mercedes. So when I give this image into my computer, which I've already trained with a bunch of images of a Tesla, the computer can tell me, hey, according to all my learnings that I've done in the past and all the patterns that I've understood from my previous images, this car is not a Tesla, which then helps us conclude it's a Mercedes, right? And so the whole reason we use computers, as I said, is because it does this whole learning process way faster than we humans ever could. So that's basically the crux of artificial intelligence. But in case that didn't make much sense, we're going to dive into a real example that will for sure help you understand this a lot better. All right, so if you guys remember, the last StarCourse class I had was we created a rock, paper, scissors game in Python. And what today we're going to be doing, or what we've done and we're going to explore, is a rock, paper, scissors game, but using artificial intelligence. So essentially, the way this game is going to work is I'm going to hold up an example to the screen, an example of either rock, paper, or scissors. I'm sure many of you guys have played the game of rock, paper, scissors with your friends. It's simple. This is a rock, this is a paper, this is scissors. And so then the computer is going to understand what image or what specific, the thing I chose, whether it's rock, paper, or scissors, the computer is going to understand it, and then it's going to compare it to what the computer has chosen. So essentially, you're playing rock, paper, scissors against the computer, and I think that's pretty cool. So let me give it a try to show you guys what I mean. Right now, I'm holding up a rock, as you can tell. I don't know what the computer is holding because it's completely random, but let's show that to the computer screen. This is a rock. The computer understands it's a rock. The computer also chose a rock. And this time, it's a draw. And as you can tell, that was just a game of rock, paper, scissors that I played against the computer. We can give it another try by holding up a rock again and seeing what the computer chooses this time. So I chose rock, the computer understood that, but the computer chose scissors this time. And so in this round of rock, paper, scissors, I won. And isn't it so cool? I literally got to play rock, paper, scissors against the computer. But let's dive deep into how this truly works. And we're going to see a lot of correlation between what is used to make this project a reality and what was just used to make that little car example I gave you, and how that works. All right. So what we first did was we trained the computer. Right? I told you guys that basically first we start out by giving our computer many images of what a specific car looks like, right? We were talking about Tesla. So we input a bunch of images of a Tesla car into a computer. And so now the computer understands what a Tesla car looks like. And guess what? It works just like that in the rock, paper, scissors game. I entered 10 examples of what rock looks like, as you can tell in these pictures. I entered 10 examples of what paper looks like in this example. And I entered 10 examples of what scissors look like in this example. And that's pretty much the basics of it. You trained the computer with the data. Then the computer went in, and this actually was step 2, which is learn and test. And it looked at all these images that we gave it, and it understood the specific features that make it up. So, I want you guys to hold up a rock right now at home or wherever you are, hold up a rock. And I want you guys to see the specific features that make it up. If you can see on my hand, the knuckles are bent in this way, and there's no fingers that are sticking out. All these things and all these features come together to create a specific rock image, or, your specific rock symbol that you hold up on your hand. And so all of these features that I just pointed out, such as your knuckles are bent or your fingers are not sticking out, the computer understands this, and it realizes it and it comprehends it way faster than we humans ever could. And that's, again, why we mainly use computers and artificial intelligence. So there's 3 steps that I mentioned. Number 1, you train your computer with many images of a certain things. I trained it with 10 images of rock, 10 images of paper, 10 images of scissors. The next step was that we train our computer to understand the features that make it up. And so that's essentially what this step did. What I did was I trained this machine learning model by clicking this button over here, and it understood basically what were the specific features that made up each the rock, paper, and the scissors. And finally, step 3, which was testing it with new data. So then this is doing step 3, going in with my rock symbol and the computer testing it and seeing how it works. And so, as you can tell, in this very simple, very cool game, we just broke down the crux and the main concepts of artificial intelligence. But I want you guys to think about something, right? We held up a rock with our hand, right? But what happens if we hold up a real rock or a real paper or real scissors? Will the computer still understand it? So over here with me, I have a pair of scissors, and I'm going to hold it up against the screen, and we're going to see what the computer thinks this is. We as humans know what I'm holding up. This is a pair of scissors. We have to see, does the computer understand it too? How is this working? So let's go ahead and do that. And this pair of scissors that I held up, the computer understood it as a rock, as you can tell from this little thought bubble. Why is it understanding it as a rock? Well, if we go back over here to our training data and we look at some of the examples we trained our rock with, as you can see, our fist is closed in them. In this example, our fist is also kind of closed, but we're holding up scissors. So how does that work? Why is the computer not understanding what we're doing? So at its core, a computer doesn't really see images. The computer just sees pixels. So I held up scissors. As you can tell in this picture, it was scissors. I'm sure all of you guys would agree with me when I say that these are scissors. But the computer doesn't understand that. The computer doesn't even know that these are scissors. The computer just understands the little pixels that make up this image. And a part of the little pixels that make up this image are me and my closed fist. So the computer just sees that, and it makes the conclusion that, hey, this is probably a rock, not scissors, because we haven't trained our computer with any examples of real scissors. Even the scissors we trained our computer with were finger scissors, not real scissors. And so that's something interesting to think about with artificial intelligence. The computer only knows what we tell it. The computer only understands what we explain to it. So basically, we told the computer that, hey, when I hold up a fist, that's a rock. The computer understands that. So if I hold up a fist again, the computer will say, hey, what you did, that's a rock. Or if I train it with saying with my finger scissors, saying that these are scissors, and I hold up finger scissors again, the computer will be like, hey, I remember you trained me with that. These are scissors. But at its core, the computer only knows what we tell it. But it's also important for us to realize that models need a lot of data points to train. So let's say I hold up a pair of scissors, right, to my screen like this. And we can see that the computer thinks it's a rock, but they're scissors. And we told it that it was scissors. But then again, if you think about it, I only gave my computer 9 or 10 different examples of what a scissor looks like. So if I gave it, let's say this example, maybe something like the background is different. And so that's why it's making this untrue conclusion that it's a rock. So in order for it to make a more accurate conclusion, what we need to do is train it with even more data and give it even more data points so that the computer understands that in even different situations, this could still be scissors. So a few key takeaways from these few past minutes is number one, the three steps of artificial intelligence, or more specifically, image recognition. Step one is train your machine learning model with examples of what you're talking about. So as you could tell, I gave like 9 or 10 examples of rock, paper, and scissors. Step two is help the computer understand the features that make up the images. So for example, in the rock, the closed knuckles, or in the paper, the fingers sticking out, or in the scissors, it's just 2 fingers sticking out. And so the computer understanding that. And finally, step three, actually giving your model new and different examples. So that's one of the key takeaways. Another key takeaway I want you to get from this is the computer only knows what we tell it. So I told you, I should have showed you guys, when I held up an image of, or not even an image, real scissors, the computer recognized this as a rock. But they're literally scissors. We know that these are scissors. Why? Well, because the computer only knows what we train it with. We told the computer that this is what scissors look like, not this. And if you look at it, I mean, finger scissors and real scissors, they do look kind of different. So that's why it didn't recognize the real scissors as scissors. It just saw my fist holding up the scissors. And so it made the conclusion, because all my knuckles were closed, it made the conclusion that it was a rock. So learning number two is that the computer only knows what you train it with. And finally, learning number three is that models need a lot of data points to train, right? I showed you guys, I held up an image of finger scissors. I trained my model with finger scissors. Why didn't it understand that my finger scissors were scissors? Well, that's because we've trained it with limited data. So sometimes our model will not always be fully accurate because we need more data to make it more accurate. So at its core, the more data you give the computer, the more accurate your results will be. All right, so hopefully this helped you guys get a little better understanding of what I mean when I talk about the 3 steps that take place in artificial intelligence, and more specifically, the image recognition part of it. But if these 2 past examples about the car and the rock, paper, scissors game were not enough, let's dive into one more example before we get into our game for today. And so we're going to pull up our visual real quick, and we're going to explore something that we actually just talked about. So I told you guys that, the computer only knows what you train it with, and I told you guys that models need a lot of data points to train. So let's say I am at the Eiffel Tower and I take my flat Stanley and I hold it up against the Eiffel Tower. And then I have my friends all do the same thing. And so these are what all of our pictures look like. All of my friends and I went to the Eiffel Tower and we took our little flat Stanley, we held it up against the Eiffel Tower, and we took a picture with it. So we have 1, 2, 3, 4, 5, 6 different images. Then let's say we trained our machine learning model with all of these 6 examples of flat Stanley. All right. And if you remember, the 3 steps of image recognition are number 1, actually giving our computer the training data, which is exactly all of this, all of the pictures of flat Stanley against the Eiffel Tower. Step 2 is the computer actually understanding the features that make it up. So certain features that the computer could extract from this specific image is, well, literally flat Stanley, as well as, the specific angle maybe that you took the picture of at the Eiffel Tower, or the certain things that even make up the Eiffel Tower. And then step 3 is going in with new data and seeing if the computer recognizes it or not. So now let's see 3 different images. Let's say we trained our model, our machine learning model, with all the examples of flat Stanley. And then we come in and we show all of these, we give our computer these specific pictures of the Eiffel Tower. What do you think the computer will do? Do you think the computer will accurately recognize these as pictures of the Eiffel Tower? Go ahead and type it in the chat. I'll give you guys like 30 seconds and I want to read your guys' responses. All right, so I'm seeing a lot of very great and very correct answers. A lot of you guys are saying no, the computer will not recognize these photos of the Eiffel Tower, and that is absolutely correct. Even though we humans are so advanced, we understand that, hey, these are pictures of the Eiffel Tower. The computer or their machine learning model, that will not understand these as pictures of Eiffel Tower. Why? Well, because as I talked about, the computer only knows what you train it with. The computer is only as smart as the information that you give to it. So we gave the computer images of flat Stanley against the Eiffel Tower. There were pictures of daytime, not at night. There were at certain angles. And so when we gave these images, they look completely different. There's absolutely no flat Stanley in these pictures. The Eiffel Towers are at night and the background makes a huge difference. The Eiffel Tower is lit up, so that makes a difference. And so the computer will not essentially recognize these as pictures of the Eiffel Tower. And so hopefully, this helped you guys understand a little bit of, how the computer only knows what we train it with. But let's look at some more examples. Let's say we take these images and we take our flat Stanley in different places of the world, to New York, to San Francisco, and all the other places, and we hold our flat Stanley against these places, and we take a picture. Go ahead and type in the chat, what do you think it'll think of these images? Again, I'm seeing lots of no's, and that's absolutely correct. It will not recognize these as images at the Eiffel Tower because, well, it's not really at the Eiffel Tower. It's not the same image. You are at different places. One was in New York and one was at the Golden Gate Bridge. So while there was the same flat Stanley, there wasn't the same background. And again, I'm just trying to convey the message that the computer is only as smart as you make it. So if you retrained the computer with examples or different examples, maybe pictures of the Eiffel Tower at night, or maybe pictures of our flat Stanley against the Statue of Liberty, maybe it would understand. I would understand what these pictures are, but at the moment we haven't trained it with that, so it does not understand what this image is. I also want to just explain to you guys that computers learn a lot like we humans do. If you remember, if we were growing up and we saw a picture of a dog or we were on the street and we were walking and we saw a dog and our parents pointed out to us, hey, that's a dog. The next time that you see a dog on the street, you'll be like, hey, I remember my parents told me that was a dog. So I know that this is a dog. They told me a while ago it was a dog, and now I'm learning from them and understanding that this is a dog. And computers learn exactly like that. We give the computer an image of a dog, and then if we give it another example of a completely different dog, the computer will understand that image 2 is still a dog because we trained it with image 1. And so it's really cool to think how computers think a lot like we human brains do, and they learn a lot like we human brains do. The only difference is that they can process a lot of information a lot faster than we humans ever could. All right, but I want to pull up our visual real quick because I want to ask you guys one question, and we've actually kind of talked about this, but I want you to go ahead and type in the chat real quick. When we're looking at a computer or a picture on our computers, what does the computer see? So when we're looking at a picture on the computer, what does the computer itself see? Go ahead and type it in the chat. Awesome. Yeah, I'm getting some really great answers. And I like this one answer, which you guys are saying that the computer does not really understand the image that we show it. And that is absolutely correct, because that's exactly what we talked about. The computer doesn't actually understand the image we showed it. It just understands the pixels that make up that image. And we talked about this several times. Let's say we show it a picture of a beautiful mountain. The computer won't get to experience the beauty of that mountain. It'll just understand that, hey, over here the pixel color is green, and over here it's blue, and over here it's yellow. That's all the computer does, and that's all the computer understands. Hey, there's a little curve over here, or there's a straight line over here. That's all the computer understands. The computer doesn't see real pictures. It sees pixels. All right. And I think this is a very important theme to think about as we transition into the little game we're going to be playing. So let me go ahead and share with you guys this game. All right, so what we see over here, this is a virtual board of the board game that I've created, which is Coder Minds. And essentially what we see is a lot of things, and we're going to dive into all of this. But through this little game, we're going to understand quite a few major concepts of artificial intelligence. And basically, it's going to be everything we've already talked about, but hopefully we'll expand on them farther and help you guys understand them farther and understand them better. All right, so let's talk a little more about the fun and the objective of this game. So we have this blue bot over here, and we want to help this blue bot get the little blue tokens and reach the end. And so we have this deck of cards, it's completely random, and we're going to use this deck of cards to the best of our ability to help us achieve this goal in the fastest way possible. All right, so let's just go ahead and dive right into it. And as we go through it, we might encounter different things, and I'll be sure to explain them. So let's take the first card off the top of our deck, and let's make it bigger so we can see what it is. So this card just says move 2 circles any, which means our little bot over here can move 2 circles in any direction. So I'm going to go ahead and move it 1 diagonal and then 1 more diagonal, because if you remember, the objective of the game is to get all of our blue tokens and then reach the end. So we're going to put this in our discard pile right over here. The next card we have is, as we can tell, it is move 1 circle forward. Fairly straightforward. There's nothing we can do to change this or play around with this one much. We just have to listen to it, place this in our discard pile, and move our bot 1 circle forward. But when we did that, here we have it. We just got 1/2 of both of our tokens. So let's go ahead and place this at our end. And this is actually going to be very significant, and we're going to dive deeper into this in a few moments. But we basically just got and achieved 1/3 of the objective of the game. Remember, we have 3 objectives: collect token 1, or part 1 of our token, collect part 2 of our token, and then reach the end. All right, let's continue on with the game. The next card I have is, again, a move 1 circle forward. So we're just going to go ahead and listen to the card and move 1 circle forward. All right. Let's continue with the next card in our deck. Move 1 circle any, moving 1 circle in any direction. I'm going to move diagonal since the objective is to get to this cookie. Or we don't know it's a cookie yet, but get to this half of the token. Right, then we have this card, and it may look a little intimidating, but let's break it down, because this actually has some really important computer science concept taught in it. All right, so let's read it first as basic English. While left not safe or left not blocked, move 1 circle left. What does that mean? Well, while the left-hand side left circle, while it's not blocked or while it's not a safe, we can move 1 circle left. So a safe is any circle that has a gray border around it, and a blocked circle is something that has another bot or another token or anything like that on it. So right now, our left is not a safe. It doesn't have a gray border around it, and there's nothing blocking it. So we can move 1 circle left. But the way while loops work is that these statements are executed over and over and over again until it's proven to be false. So we keep on doing this until it's not true anymore. While the left is not safe, while currently the left is not a safe, is it blocked? Nope. So we move one circle left. And again, remember, as I said, it's keep on being executed until it's proven to be false. So that makes us move again left and then left until we have gotten this half of the token. And boom, let's put it at our end, and we're going to explain and look into that a bit farther. But literally, as we just saw, in one card, we went all the way from here, I don't remember where we were, somewhere around here, and we went all the way here in just one card. And that is the power of while loops. So it's basically executing a certain line of code over and over and over again until it's proven to be false. And that's exactly what was just done here. And when it was proven to be false, when we were being blocked by the cookie, we stopped executing it. And that's the end of the card. So let's go ahead and move it back to our discard pile. And let's look into our next card. And this next card is basing off that same concept. So let's see if we can do this again. While the forward is not safe or the forward is not blocked, move one circle forward. And if we remember, the way while loops work is it's kept on being executed until the statement is proven to be false. So the first time it's executed, it goes over here. And then it's executed again because the safe again is not, or the forward is not a safe or it's not a block. So we move forward. And then let's go through it again. Is the forward safe? Well, it is a safe. This is, as I mentioned, the gray circles are safes. So that means we can no longer execute this statement. And that is the end of it. That's when we know we have to discard it. So basically it was a safe. And so that means it is the end of it. Let's go ahead and put this in our discard pile. And the next card is also an advanced card, but this one is a little easier. So let's also dive right into this one. If the right is safe or the right is not blocked, move one circle right, else move one circle left. So that may look super complicated, but it's actually really simple. You can think of it as a cause and an effect. So the cause is our right safe? Nope, the right is not a safe. Is the right blocked? Nope, it's not blocked. So we move one circle right. But that's the end of it because it is an if statement. If we remember, the ones where we keep on executing it until it's proven to be false is a while statement. So we learned about two different types of coding concepts, which were the if and the while loops. So to quickly summarize, while loops execute something over and over and over again until it's proven to be false, and an if statement only executes it once, but it's more of a cause and effect. But since this cause was proven to be right, we go ahead and went with this. Right? So that's the end of this card. Let's go and put it in our discard pile. And then we're just going to continue on over here. Our next card is telling us to move one circle right. Let's go ahead and move one circle right and discard this card. Move one circle right again is our next card. We're going to go and do that and discard it. And then we have a move one circle forward, which is perfect, where it's helping us achieve our goal. One circle forward. And our last card is also a move one circle forward. And that's it. We achieved our goal of getting both halves of our token and reaching the end. And we did it in a very efficient way because we had while loops and if statements to help us out with this. But now let's break down how what we did right now is actually AI. All right. So number one was feature extraction. All right. So we humans, I'm pretty sure most of you guys could tell by now that this image right over here is a cookie, right? It's a cookie. I think you guys could understand that. We humans know that because we are shown what a cookie is. We've eaten cookies in our life. We've seen at least images of different types of cookies, but you know what the computer may have not ever seen a cookie before. So instead what it did was feature extraction. We took one image and we broke it up into two different halves, and the computer extracted specific features that make up this one cookie image. So we can see maybe these are chocolate chips or they're raisins. And it understands, all right, so there are certain raisins or chocolate chips, and then it has more of this beige tan color around it. And then when they come together, this is what makes up a cookie. And so when the computer makes that final decision after understanding the patterns and the features that make up the cookie and understand that, hey, this is for sure a cookie, that is called classification. Basically, after seeing enough patterns to make a confident definition or confident decision. All right. And once again, the computer actually still doesn't know it's a cookie. The computer just understands the little pixels that make up this image, and then they attach a label to it. And the label in this case is that it's a cookie. So if we go in and we show the computer another example of a cookie, well, maybe it might be, and then we don't tell it that this is a cookie. We just show the computer an image. So what the computer is going to do, it's going to dive deep into the pixels that make up the image. It's going to extract those specific features, and it's going to compare it to the features we have of this defined cookie over here. And if they're similar, the computer is going to make the conclusion that this new image is a cookie. And if it's not similar, it's going to make the final conclusion that it is not a cookie. All right. And so at its core, that is what image recognition and image recognition part of artificial intelligence is. But, I want to sort of break it down, and I want to review some of the things, and I want to review what we did right now with all of you guys. So first of all, we learned a little bit about while loops and if statements, right? We understood that while loops are something that's repeated over and over again until proven to be false. We understood that if statements are conditions that are only executed once, but they are more of like cause and effect, which can be very beneficial to us in our code. We understood the feature extraction, which was understanding the specific features that essentially make up an image. We understood, hey, these are little dots over here. These are, chocolate chip, or these are raisins. And then we understand, hey, there's a tan, there's a beigeish color around here. These are all specific features that make up a cookie. Hey, it's round. That's another feature. And when we put them all together, we make the final decision that this is a cookie. That is classification. Seeing enough of a pattern to be able to make a good and confident final decision. All right, so hopefully these few examples that I just shared with you and that I just gave you helped you guys really understand what artificial intelligence is. And so those of you guys who said no in the beginning, no, I don't feel like I have a confident understanding of what artificial intelligence is. Well, maybe now you have a little bit more confident idea of what it is. So let's just review and recap some of the things we've learned so far throughout all of our 4 examples in today's class. Number 1, there are 3 steps when working with artificial intelligence. The 3 steps, step 1 is to train our computer with a bunch of images of what we're trying to classify. Step 2 is the computer actually breaking it down and understanding the features that make up the image. And finally, step 3, which is giving in the computer a brand new image and the computer making a confident and accurate decision and conclusion that this is a certain image. And those are the 3 key steps of how artificial intelligence really works and is broken down. We covered some more points here and there, and we can quickly go over them. We talked about how a computer is only as smart as you make it. If we only train the computer with 9 images of rocks and 9 images of paper and 9 images of scissors, well, then the computer will only be able to understand those the hand motions that you hold up that are similar to those 9 examples. Whereas if I trained a computer saying that, hey, this is scissors, and then I hold up this, the computer won't understand these are scissors because it won't see anything like this hand motion. It'll just see that my hand is bent and there are knuckles. And if the computer knows, hey, this is what a rock is, when I hold the scissors like this, it'll just think this is a rock. because we didn't actually train it with any examples saying that when I hold it up with something like this, those are scissors. So a computer is only as smart as you make it. And in order to make it smarter, and in order for it to make more accurate conclusions and predictions, we need to train it with even more data. So if I gave the computer data that, hey, when I hold something up that looks like this, these are scissors. Then if I showed it again to the computer will be able to make the accurate conclusion and prediction that these are scissors. And similarly, if we held up flat Stanley against the Eiffel Tower, and then we showed it at daytime, and then we showed the computer pictures of the Eiffel Tower at nighttime without flat Stanley in the frame and at a completely different angle, yeah, we humans know that is the Eiffel Tower, but the computer doesn't, because that's not what we trained the computer with. So the computer is only as smart as you make it. We explored some coding concepts that are really helpful, especially when working with artificial intelligence, because yes, we need to train the computer. The computer needs to do the feature extraction and the classifications, and it needs to be able to make predictions on new images. But how does it do all this? We can't literally just give an image to the computer and say, here, eat it, take it in. It's all code that does that. It's all code that takes in the image, that does the processing, and then when we put in a new image, it makes a new conclusion. That's all code. And so when we explored while loops and if statements, those are two examples of certain codes that we use when we work with artificial intelligence. And finally, the last and most important thing I wanted to review was that a computer doesn't see pictures. A computer doesn't see images. A computer sees pixels. It understands only the pixels that make up an image. So unfortunately, the computer will never be able to see a beautiful mountain or a beautiful sunset that you give to it. It'll just see the pixels that make it up. And it only understands those pixels when it makes new predictions and new decisions. But that's the end of it for me. I hope you guys enjoyed it. I hope you guys learned something. I hope you guys took away what artificial intelligence is, and I hope you guys have a better understanding than you did 40 minutes ago. Thank you for joining me.
Awesome. Hey, thanks so much, Samaira. I know I'm feeling a lot better about my human intelligence, about what artificial intelligence is right now. That was fantastic. We're not done yet, everyone. Make sure a couple of things. You guys have been asking some amazing questions. We are about to get you answers. And so start firing in those questions as you have them. We'll do about 10 minutes of questions and answers and ask Samaira as many questions as we can to get all those answers. But we also promised everybody an opportunity to win Coder Minds, the board game that Samaira was showing off, and a spot in the Varsity Tutors after school club of your choice for this fall. And so now is your time. If you've got a camera ready, we're going to turn it back full screen to Samaira in just a second. You guys will get to see the game itself. And a reminder, if you take a photo right now, post it on Instagram. We'll have the official handles up on the way out, but it's Coder Bunnies, which is Samaira's other game, and Varsity Tutors. You'll be entered to win that prize package. So Samaira, let's go back full screen to you and we'll get everybody those pictures.
Awesome. All right, guys, this is my board game Coder Minds. Yeah, we can go ahead and take a selfie with it.
All right, perfect. Thanks so much. And you guys, we'll have Samaira on full screen when she's answering questions as well. So if you didn't get the perfect picture this time out, that's okay. Your your phone just recognizes the pixels. It won't be offended by it not being your best. We'll give you more opportunities to get that perfect picture here in just a second. We got some great questions, and one of my favorite kind of themes out here was a little bit of like, okay, so AI is only as smart as we train it to be, is one. And if we have to tell AI over and over again, this is a Tesla, this is the Eiffel Tower, when does the machine really become smart, and what can it do with that? Is it limited to just knowing what something is? And I think you and I both know that no, it can now take that information and go do something. Can you tell us a little bit about what's next once we've trained the model and it knows how to differentiate between things?
Yeah, I think that's a fantastic question. And I actually want to answer that question with another question for all of you guys to answer. I want to ask you guys, we understand, hey, we're using it very limited right now in this class and in these examples to just recognize images. But I want to explain to you guys, I want to emphasize that AI can be used for so much more and in so many more fields. But before I get into that, I want to ask you guys, what is something that you wish that you could change about the world? There could be literally anything. Just go ahead and type it in the chat because I want to actually prove something to you. If we can pull up the visual real quick. What is something, literally anything, you wish you could change about the world? And we're already getting some fantastic answers coming in. We are seeing people want to solve the poverty or bullying or inequality. The sickness, wish that nobody would ever get sick. But what if I told you all of these things that you put in right now, they could all potentially be solved or at least made progress towards with the power of AI. And AI can be used for so much more than just recognizing that, hey, this is a rock or this is a paper, these are scissors. It can be used to literally save human lives. In healthcare, for example, we are over here sitting in, I'm sitting over here, I live in California, and let's say I grow up and I become a doctor, and I become such a great and such a fantastic doctor that somebody all the way across the world in Africa wants my help and wants, let's say me to do a surgery on them. But let's say I couldn't be there in Africa at that exact moment. So not right now, but in the future, artificial intelligence is so powerful that by sitting over here in my home in California in the United States, I could be helping someone on the total opposite side of the world using the power of AI. And while there's nothing exactly like this right now, AI is so powerful that it is possible for things like this to exist. And then there's just so many other fields too. We can think of education. I just came home from school today for this Varsity Tutors course, and I'm so excited to be here. But even just thinking about education, we all learn at different paces. We all have different styles of learning, different methods that help us. And there are teachers, we have one teacher for every 30 students. And a teacher can't create a personalized curriculum for every student. But AI can, and AI has the power to adapt to every student's levels, goals, learning pace, styles, forms of learning, and it can be used to help you do better in school and help you achieve your true potential. And there's so many other fields I could just touch on and explore, just your safety. Let's say there's about to be a big storm or a violent event. Artificial intelligence can help us give warnings well in advance. We can think about our self-driving cars or self-flying planes. Of course, that is nothing that exists right now, but it's definitely something in the future. It's important to realize that humans make judgments that can be clouded by fatigue, inexperience, and so much more. Whereas machines, they don't have any of that bias, any of that fatigue, any of that. They know what you've trained it with. They will see the situation, and they know exactly how to respond. So AI is so powerful. And in today's class, we just explored some really basic flat Stanley against the Eiffel Tower or simple rock, paper, scissors hand motions. But it's actually so much more powerful, and it can be used in so many more things, and it will be used in so many more things in the future.
Thank you for that. Yeah, I think that's really powerful. And it's so fun to hear you talk about it. I think today, we talked about, how do we classify a cookie or the Eiffel Tower or paper, rock, scissors, but think about that power. If you're able to, in medicine, train AI to recognize what is an X-ray or a CAT scan of early signs of, heart disease or cancer look like. And then when it sees that, it flags the doctor and says, hey, we've seen this pattern. One doctor may be able to look at 100 scans a day. AI can look at tens of thousands of scans in a day. And that predictive power that I know you talked about early on is so important. Or when, we're, the CAPTCHA, we use that example when it says, show us pictures of fire hydrants or pictures of crosswalks, and you have to click those to get onto a website. You're training AI to be able to make those, whether it's safety features in cars or all those. I think that's really important. We had some fun with it with some fun examples today, but AI is doing some really powerful things by recognizing early signs of things that we want to be careful about or get ahead of. So another fun one for you. One of my favorites, somebody asked, like, I have Alexa in my house. Is that AI?
Yeah, that absolutely 100% is AI. We talk to Alexa. We're like, hey, Alexa, turn off the light. How does Alexa know what we're saying? How does Alexa know we're asking it to turn off the light? Well, because of artificial intelligence. The people who created Alexa, Amazon, they have trained this mini robot with so many examples of different people and different ways of people asking it to turn off the light. And so when you go ahead and tell it to turn off the light, it goes back, it refers to everything it's been trained with, and it sees, hey, oh, what she's asking me is to turn off the light. So let me go ahead and do that. And that quite exactly is AI, and actually just falls under our 3 steps. It started out with the creators of Alexa training it with a bunch of examples. Alexa itself going in and understanding what are the different words, the different phrases that make up your little question, asking it to turn on or off the light. And finally, more examples, or training it with new examples, which is us literally asking Alexa to turn off the light. And this was just one example of how it can be used. There's so many more examples. Like, let's say I ask Alexa to play a certain song for me, and then it plays a song, but the next song that comes up is a song very similar to the song before. Well, how did it know my music taste? How does it know which music I like? Well, all because of artificial intelligence. It understands certain things that make up, or certain components or features that make up the first song that I requested to play. And so the next song it plays based off more prediction. It has those same features or same patterns. And, the whole world around us, a lot of it is actually made up of AI if we look closely.
Thank you. Yeah, it's really powerful. It's predictive power. We train it to think like us, and then it gets to make predictions off of all that information, which is really, really cool. So thank you so much for that. Hey, one other question I thought was great. If you can get into this a little for us, and you kind of showed a little bit with the neural networks and in the board game and all those kind of things. Someone asked, I want to make sure I get it right. Said, hey, is it only looking when it's trying to determine what a dog is in a picture? Is it only looking at the outline? What else is it looking for in between? Can you tell us a little bit more about sort of, we know it only sees the pixels, but what kinds of things go into that prediction? Is it outlines? Is it, anything else? Size, ratios between things? What can you tell us about what AI is looking for in image recognition?
That's a fantastic question, and absolutely. So let's just take an image of a dog, right? What does the dog have? Well, a dog obviously has 2 eyes. It has a different nose, unlike, humans have a nose. It's a little different than that. A dog has a different body shape. It has a certain special body shape. It has a tail. So there's very specific features that make up a dog. And so when a computer looks at an image of a dog, it looks at those features. It looks as, hey, okay, the eyes are over here, the nose is over here, and the nose is shaped in a certain way. Hey, the tail is coming out like this, or the tail is bushy over here like this. And so it looks at these specific features, and that's basically what it understands. And, I think you talk about ratio or aspect. Yeah, it noticed, hey, okay, there are 2 eyes, but the distance between these 2 eyes are, let's say, 1.5 inches, for example, or 2 inches. And so it looks at that too, and that's an important part of it. But really, the different features that make up a dog is what the computer looks at.
Cool. Thank you. And that's what's really neat, I think, about AI too, is that we may not be able to define really easily what a dog is when you think about all the different breeds and sizes and ages and all those kind of things. But AI is constantly looking for what are those definitive features that makes a difference from a horse or, an elephant or all those kind of things. And it's coming up with its own definitions that it might not be able to explain to us, but because it's seen millions of pictures of dogs, it's figuring out exactly those definitions. So, hey, we had a lot of questions about you also. We've got a lot of kids out here who obviously are taking time after school to learn about tech, coding, AI, and all those kinds of things. And so one was, kids who think, hey, I've got great ideas. Samaira's got great ideas. She was able to capitalize on those. What advice do you have for people who, got brilliant ideas or tinkering and working on cool things, but don't know how to get it out in front of the world. It's like you submit it for a school project and you get a grade on it, it comes back. What did you do to be able to take your ideas and actually, turn them into businesses and opportunities to reach the world?
Of course, that's a fantastic question. And for me, it was really about networking. And that sounds like a big word and a word that probably doesn't make sense. But networking is really just talking to people who are important to you. We're talking to people who are important to your certain project and who can help you connect with other people. So let's give like one example. Let's say I'm working on this fantastic science project I have. And I'll talk to my science teacher and I'll tell her about this idea and I'll be like, hey, do you know anybody who can help me maybe take this science fair project and take it to my, let's say, city council. Let's just start with my own city. And I want to present this idea to my mayor and see if we can implement it in our city. So it's all about, talking and getting in contact with the right people. So I have a science fair project idea. Let's say it's a way for me to save water. And I want to implement it in my city because my city has a drought problem. So I'll go talk to my science teacher. Maybe my science teacher has connections with this person who is a part of the city's council. And this city council person is in contact with the mayor. So all of a sudden, because I know my science teacher, I know the mayor of my city. And I can present this solution that I have to the mayor and possibly implement it and possibly bring the idea to the world. And so, you have to have that basis of the idea, how it's going to be carried out and how it's going to be implemented. But once you have the idea, it's all about getting in contact with the right people and getting in contact with the people who will help you bring your ideas to the greater world. And that's basically what networking is, just talking with people and helping, their connections help bring your ideas to the world or to wherever you want to take it.
That's great advice. One thing I'd add to that too is when you're young, people do want to help you a little bit more than when you're older, right? So if you're 30 and have a great idea, the may or may not want to hear about it. But if you're 12 and it makes a great story in the newspaper or on the city website or any of those kind of things, like don't be shy because you're young. It may work in your favor because it's just such a cool photo opportunity for whoever at the company or government that might want to be part of it. If you've got cool ideas, they're not hearing from as many folks like you, and so at least someone will probably jump at it if it's a good enough idea and you come across as professional and all those kind of things. So, so there's been one last question, one of my other favorites out here. Thanks so much to all of you for asking such great questions and for so much participation tonight. We've got a lot of kids too who are they're shy. They know they love working on cool projects and things, but maybe they're a little too shy to speak up in class or to ask for that kind of networking help and all those kinds of things. What's your advice for shy kids who love tinkering, have great ideas, but haven't really been able to show that off just because they feel they're not sure the idea is quite good enough, or they don't want to raise their hand in class and those kind of things? What's your advice for them?
I think, my biggest advice would be, number one, you have to believe in yourself. If you don't believe in yourself, no one else will. And I think you have to always be your biggest cheerleader, your biggest supporter, because, at the end of the day, you always have yourself. And so you need to believe in yourself. You need to believe in your ideas, and you cannot let other people bring you down. One thing I like to live by is never take criticism from someone you never take advice from. It's really important for you to not be affected by the people around you, the people who may want to bring you down, or the people who don't always support you. And it's important to remember that all ideas are great ideas. And, it starts by you believing in yourself. And, you can start, if you want to, let's say, present your idea to your science teacher, you can start by maybe presenting the idea to your parents. And then maybe trying to, talk to your parents about your idea, maybe prepare a little summary or a short little, blurb that you're going to say to your science teacher or whoever this idea you're going to bring this idea to the world with. And it's about believing in yourself and maybe some practice, but at the end of the day, it's always about your self-confidence and just believing in what you do and believing in your work.
I love that ideology of never take criticism from someone you wouldn't ask for advice. I think is really good. Sort of, I think sometimes we're shy because we're focusing on people who I don't say don't matter, but aren't really in a position to support us, be our cheerleader, give us those opportunities. And so, if you're worried about pleasing them, then you're not focusing on the people that could actually help you and all those kind of things. So really amazing advice, Samaira. Thank you so much for a fantastic presentation. Such great examples. One last one real quick. If people want to play with that AI software, that's available to anyone, right? Where's what you use for paper, rock, scissors? Where can they find that?
Yeah, absolutely. Anybody can go ahead and just play with the software. It's completely free, accessible to everybody. The website is machinelearningforkids.co.uk. I can go ahead and spell that out for you real quick. MACHINELEARNINGFORKIDS.co.uk.
Awesome. Perfect. Thank you so much. That's also a good plug for this is recorded. So if you missed any of it or have friends who you think would benefit, you can come right back to this link and check it out a little bit later to get that URL, to check out Coder Minds a little bit more and all those kind of things. Last couple of things we won't even have to spell out for you because they'll just come right up here on the screen. Here are the handles. You guys took some amazing pictures tonight. I'm sure if you want to put them up there and I may do a little facial recognition on you or something like that. But if you tag those handles, you'll be entered to win. We're not set up to know exactly who you are at. So tag us at Varsity Tutors, tag Coder Bunnies, that's Samaira's company. You'll be entered to win that prize package of your own copy of Coder Minds and a spot in a Varsity Tutors after school club. So we hope to see all of you back here soon for some of those club sessions, for future classes and all those kind of things. Thanks for all your questions. Thanks for those photos. And Samaira, thanks so much for another amazing class.
Thank you so much for having me. It was my pleasure to be here today.